Hello friends, today we'll try to solve this problem. This statement or this numerical is from laws of motion, first year PUC or class 11 physics. A mass of 200 kg is placed on a rough inclined plane of angle 30 degree if coefficient of friction, limiting friction, is 1 upon root 3. Find the least force in Newton acting parallel to the plane. Okay, so this problem is based on a block on inclined surface. This is given 30 degree, and one block is kept here like this. Okay, so first of all we will find the forces acting on this body. So here this mass or weight of the body will act vertically downward. Okay, now normal reaction perpendicular to the surface. Okay, surface will act in the perpendicular direction like this. Now the tendency of the body is to move downward because this is the inclined surface, so definitely friction will act in this direction. This is the frictional force. Okay, now to find the force balance in this case, what we have to do, we want the forces in horizontal and vertical direction only. Here two forces are inclined. Okay, this is vertical, but this force is inclined, this force is inclined. So we have to resolve this force in this direction, two forces. This force in this direction, two forces, 2 plus 2 plus 1, 5 forces. So problem becomes complicated. So I have another option to solve this. How to solve? You assume your x-axis here. No problem. And perpendicular to this, we will have a y-axis in this direction. Okay. So this force is along x-axis. This normal reaction is along y-axis. No problem. Okay. So now this mg becomes inclined force. So you resolve this only. Means what we will have? 1, 2 and these two components. Only 4 forces we will have. So we can minimize the forces. Okay. Now look. Now what you do? You resolve this mg. If you want to resolve this mg, this angle is theta, this angle is 90 degree. So this angle will be 90 minus theta. So definitely this angle is theta. And this theta is equal to 30 degree. Okay, so this angle becomes 30 degree. So this component will be mg cos theta, means cos 30. And this component perpendicular to this will be mg sin 30. Okay, so now look. Now first question is what? Find the force parallel to the plane, means in this direction, parallel to the plane. Okay, so to keep the mass sliding down. Means what? Means a force. Now look, these two forces may balance each other. Okay, this force, due to this force, body may slide in this direction. Okay, in the opposite direction, force will act in that direction. They will balance each other. If not, means this friction force is not able to balance this force, body will come down. We have to stop this. Okay, this have a limiting value that is equal to mu n. Based on this mu value and based on this normal reaction, that is having a fixed value, limiting friction. So if this value is equal to this will remain stationary. If this value mg sin theta is more than mu n, then this will go down. Okay, but we have to find the force which is required not to move this block. Means this block should not move down. That force we have to calculate. Okay, we have to calculate that force which we have to apply on this to keep this body. Okay, to keep this body stationary. This force we have to apply. Okay, so first of all we will see whether this mu n is equal to mg sin theta or not. If not, then we have to find that force. Otherwise, if these two are balancing each other, naturally this force becomes 0. No need to apply external force to stop this motion. Okay, so mg sin theta is equal to what? mg sin theta is equal to m is what? So this force mg sin theta, mg sin 30 is equal to, this is 200 into g, let us take 9.8, or you can take 10 also. Okay, sin 30 is 1 by 2. So this becomes how much? 98 Newton. Okay, this becomes 98 Newton. If you take this 10, this will become 1000. That is also correct. So 980 Newton. Now let us calculate force, frictional force mu n. For that you need n. So n can be calculated. This is the force balance. This n is equal to this value. So n is equal to mg cos 30. So this will become m is 200, g is 9.8, or you can take 10 also. Cos 30 is root 3 by 2. So this force is how much? These two ones are 2. So 980 root 3 Newton. Okay, this much is the force. Okay, now let us calculate friction force. Friction force is equal to mu n. So mu is equal to 1 upon under root 3 into 980 under root 3. So this is equal to how much? 980 Newton. Now observe this value mg sin theta. So this is equal to how much? 980 Newton. Okay, and this friction force. Okay, this friction force. This value is how much? 980 Newton. Correct or not? Now look. This n and this mg cos theta are balancing each other. So there is no question of this kind of motion. Okay, now this 980 is acting on this side, this 980 acting in this direction. So these two balance each other. So there is no question of movement of the body in this direction or in this direction. Body is stationary. So how much is this force? 0, because no need to apply additional force, because body is already stationary, and that is what they are asking. So to keep the mass from sliding down, we should stop this motion. We should keep this body stationary. What is the force required? Additional force required? No force required, because body itself is balanced by this friction and weight. Okay, weight mg cos theta, mg sin theta is acting in this direction, friction is acting in that direction, and both are balanced. So for this, additional force required is 0. Additional force required is 0. This is the first answer. Got it? I hope you understood. Now second is what? Second question is to move the mass up plane. Means now the body is stationary. Now we have to apply additional force for this upward motion. So let us say this F we have to apply. Means this, if you increase this, okay, so it will move in the upward direction. So how much we can apply? Now here you must see this carefully. You must understand the force balance here. Now look, if I want to apply, I want to move this body in the upward direction, I have to overcome this force first. 980 Newton I have to apply first, because it is acting in this direction. I have to apply additional force on this side, 980 Newton. Okay, so 980 Newton I have to apply. Due to this, what will happen? When this 980 and I have applied external force 980, these two will balance each other. Okay, now, and due to this force, body may go in this direction, but at that time friction plays another role. Now initially what is happening, this force is acting downwards, so tendency of the body is to slide in this direction. That is why friction was acting in that direction. Okay, but now as we have applied 980 Newton extra force, tendency of the body is to go up. So friction will act in the opposite direction. Friction will act in the opposite direction. So that this value and this value is fixed, because it is limiting value mu n, that will not change, 980. So this 980 will act in the opposite direction. Means again we have to overcome that force also, because we have to move in the upward direction. We have to lift the body in the upward direction. So this 980 plus this 980, these two forces we have to overcome. So this comes to be 1960 Newton. So 1960 Newton we have to apply. This force we have to overcome, this force, and this force also we have to overcome, because friction is started acting in this direction, because it will act always in the opposite direction of the motion. It will try to oppose the motion. Getting or not? So this 980 plus that 980. total 1960 Newton force we have to apply additional, so that we can move the body in the upward direction. Understood or not? See, first of all, see the force balance. For that purpose, what we have done? We have resolved in two directions. Okay. So this mg we have resolved in two directions. mg, this angle is theta, so this angle automatically becomes theta. So mg cos theta, and this will be what? Mg sin theta. Okay. Now this force is not there. Okay. And now this another force on this F and Newton. So in the first case, these two are balancing each other, these two are balancing each other, because answers are same. So body is not stationary. So no additional force is required to move this body in the downward direction or in the upward direction. No force, additional force is required, because already these four forces are balancing each other. Okay, so body is in equilibrium. So this is your first answer. Secondly, what we have to do? Now body is in equilibrium, we have to add this force to move this upward direction. When this force, some amount of force we will apply, this is acting in the downward direction. So this force will act, we have to overcome. So first we have to apply this much force. This much force is 980 Newton. Due to 980, body may move up, but friction will play in the what is the role of friction? It opposes the motion. Now motion is this direction, so friction direction will change. It will act in this direction now. Again this force we have to minimize, overcome. So to overcome this force means again additional 980 we have to apply. So 980 plus 980, 960 we have to apply in the upward direction. Okay, so this is the answer of the second. So I hope you understood. Okay, so if you are not subscribed to my channel, please subscribe. Share the link to your friends. Okay, if you understood, write in the comment box. If not understood, write in the comment box. So I will try to explain in different way. Okay, so thank you very much.